Take. என்ன டவுட் அது சொல்லு. நான் அனுப்ப சொன்னேன்ல. அனுப்பிச்சு அனுப்பல இல்லை. அப்புறம் என்ன? Those are online. Are you able to hear me?
Yes, sir.
Those are online. Are you able to see my screen?
Yes, sir.
Shall we get started? Hey. Enough. நீ வா ஃபர்ஸ்ட் இங்க வா. நீ இங்க வா, சீக்கிரம் வா. டைம் வேஸ்ட். சீக்கிரம் வாடா. சீக்கிரம் வா. சித்த இந்த பக்கம் தான் இருக்காது. சொரதஸ். சரி, பார்த்துக்கலாம். Okay, shall we get started? So in the previous class, what were the concepts that we discussed? We saw the introduction of what is an alternating current, right? And we saw what is the difference between alternating current and direct current. Then we saw that the average value of an alternating current over a complete cycle is going to be 0. We saw the derivation for it. And we derived the average value of alternating current for half cycle. We know that the average value of alternating current is defined only for half a cycle, right? And what is the value that we got? It is just corrected. It is 0.63 times E naught. It is not 0.67. It is 0.63 times E naught. Okay, I wrote it as 0.67, no? 0.63 times E naught. Or I is equal, sorry, if it is I naught, if you're writing for I, it is 0.63 times I naught. If you're writing for E, it is 0.63 times E naught. Okay, so these two are the values. Now, we are going to see the next and the most important topic, that is the RMS or it is also called as the root mean square value of AC. So there are three names associated with it. One is called as the root mean square. It is also called as the virtual or effective value of AC. I'll tell you why those names are actually given. Okay. First, let's try to understand what is the definition of it. Okay. So listen. It is defined as that value of direct current. So why we generally don't deal with AC directly is because it is an instantaneous value. E is equal to E naught sine omega t means at every instant it keeps changing, which is difficult for us to calculate. So to calculate, what we do is we find an equivalent value of that AC in terms of DC. That is why if you see the definition of average current, average value or RMS value, both are given in terms of direct current. So it is defined as that value of direct current. What is the direct current going to do? The value of the direct current, which produces the same heating effect in a given resistor as produced by the given alternating current when passed for the same amount of time. So what I'm trying to tell you here is, let's say I give you a bulb, right? We know that bulb also has some resistance associated. And we know that if you talk about a tungsten bulb, I'm not talking about the LEDs. LEDs work on completely different principle. Tungsten bulbs work on the heating effects of electric current. We know this, right? So when you take that bulb and connect it to a DC source, right? What is obviously going to happen? If the DC source is sufficient enough, the bulb is going to get lit, right? Now what I can do is I can take the same bulb and connect it across an AC source also. Can I do that? But the only difference is when I connect it across DC, I'm going to be clear that this is the value of the EMF produced by the battery that I've connected. I'll be sure about this value at least for some time. Right? I buy a new battery, I'll be clear. Okay, if it's a 12-volt battery, it is going to be 12-volt only. Right? Let's assume that there is a 12-volt battery. I'm just taking some random number. Don't worry about the number. Just to explain. Okay. This 12-volt is going to be what value? It is the DC value. But can I say that the alternating voltage is 12-volt? It doesn't make sense. If I say it is 12-volt, I'm trying to say that the magnitude is constant, but we know that the EMF is going to change with respect to time. So I can only write it as E is equal to E naught sine omega t. If I observe this, right, there is some important pattern that I can take out. One is E varies with respect to time, whereas E naught is constant. Am I right? So E is going to vary with respect to time, but E naught is constant. Why is E varying with respect to time? It is not because of E naught, it is rather because of the sine function. So if I am able to establish a relation between this 12-volt and E naught using the heating effects of electric current, then that value I am taking out of that AC is what is called as RMS value. So why I'm giving this hint is the final value of RMS that I'm going to derive will be in terms of E naught. That is first thing to be registered in your mind. So this is the overall outline of the story. But the second most important point is understanding about how the bulb is going to glow. So if I connect this 12-volt bulb, it is going to glow with some intensity. Am I right? So let's say the intensity is I. Now suppose I decrease the value from 12-volt to 9-volt. Is the bulb going to still glow with the same intensity, or will it be less or more? Obviously less, because the voltage that is being supplied is decreased, right? So this 12-volt, let's fix to the 12-volt. So 12-volt is giving us some amount of brightness using the principle of heating effect of electric current. Now what will happen is the same bulb can still work on AC also. The bulbs which we are connecting at home are all using the AC only, because we switch on here. We don't directly connect it to a battery. Makes sense. So when you do that, I need to find that one value, right? One value from this E naught, like how much, what is a multiple of that value with E naught, which will be equal to the 12-volt, so that it can give me the same amount of brightness. So if I'm able to find that, then I'll call that value as what value? RMS value. Okay. So let me show you the derivation. Then I'll explain practically how it works. Okay. Listen to this. So I RMS is represented as I with a subscript RMS, or you call it as IV, V stands for virtual, or you call it as I EFF, EFF stands for effective. All the three are the same, but mostly we'll use IRMS only. So the previous class, if you remember, right, in the previous lecture which I delivered, in that I told you that how the average value is written. You remember I connected the discrete and the continuous values, right? So from the discrete value, you can say whenever you have continuous, you write it as integral of I dt divided by integral of dt. So and you will take the proper limits. Are you clear with this point? Now, if I need to write the value of I RMS, you need not memorize it. Okay. Just look at the term, it will give you the hint. Root mean square. So I'm looking at the word mean. It is a mean of whom? It is mean of the square values. It is not mean of the direct values. It is mean of the square values. So what I'm doing is, since I'm interested to find IRMS, I'll take the average. So when I need to take the average, there is only one formula. What is it? Integral of whatever is the function, write that function, times dt divided by integral of dt. So I need to be careful with what function I should put here. I need to put the square of I. Am I clear till this point? So if you look at this, is this not looking like the average value? But this is the average of whom? Average of the square value, right? But what is the topic? It is mean square, but what is the prefix that is used? It is root. What root? Square root, cube root, what root is that? It is square root. So if I'm able to calculate this value, this is what is going to give me IRMS. Did you understand the story? So what are we supposed to do? First, write the average of the square and then take the square root of it. So don't take the square root of the numerator alone. You should take the square root of the average itself, because it is a square root for mean square. Am I clear till this point? After this, it's only mathematical data. Actually, how this is derived is using the heating effect of electric current. If I use it, you will get confused. Okay, that is why I directly wrote it. Okay, so after I finish this, I will tell this how this equation is actually obtained. Okay, so tell me one thing. Did you understand? Did you get some idea of why we are connecting the DC to AC? It is something related to the extent of brightness that is produced in the bulb by connecting it to DC and connecting it to an equivalent value of AC. Okay, so listen to this. Now, our job is to find integral of I square dt by integral of dt. And what I will do is I'll take the limit as 0 to t itself. I'm going to calculate it in one time period. But remember, this value will not come out to be 0. It is the average of current that will come out to be 0, but not the average of the current square. I hope you are able to understand. So I will take only the value that is within the square root. In fact, not even within the square root. I will take only the numerator, solve it separately, and I'll then put it back here so that I'll get the value directly. Okay, so what is the numerator? The numerator is integral of I square dt between 0 to capital T. So this will be equal to integral of 0 to t. What do I write the value of I as? I is I naught sine omega t. So I is equal to I naught sine omega t, but this is within a square times dt. Right. So this will be equal to how much? I naught square into integral of sine square omega t dt between 0 to capital T. The only problem is we don't have a direct integral of sine square. We only have the integral of sine. So what we need to do is I naught square into integral of sine square omega t can be written as 1 minus cos 2 theta, that is cos 2 omega t divided by 2. So just to give you an information, basically cos 2 theta can be written as 1 minus 2 sine square theta. So rearrange the equation, sine square theta will be equal to, so 2 sine square theta this side, cos 2 theta that side. So 1 minus cos 2 theta, the whole divided by 2. That's what I use. Instead of theta, you have omega t. Okay. So don't forget with respect to which function you're differentiating. Now this will be equal to I naught square right, into what is going to be the integral of half? It is t by 2, right? Remember, the limits are between 0 to capital T. Minus, what is going to be the integral of cos 2 omega t by 2? It will be sine 2 omega t, the whole divided by 4. Because there is already a 2 here, into this 2 will come in the denominator. Okay. So this is also going to exist between 0 to t. Now substitute the limit. I naught square, I'll take the 2 outside. I'll take the 2 outside. So what am I left out with? I'm left out only with t here. So when I have small t, substitute the upper limit. It is capital T minus the lower limit, 0. Minus, what am I left out with here? 1 by 2 is left out because I took only one of the 2's outside. So for sine 2 omega t between 0 to t, what should I write? Sine 2 pi by capital T into t between 0 to t. Am I right? Am I right? So I naught square by 2 into, this is going to be t, minus half into, substitute the upper limit, sine 2 pi by capital T into capital T, minus sine 2 pi by capital T into 0. Right? T and T will get cancelled. What is sine 2 pi? 0. Sine 0 is 0. So this value will completely get lost. Okay. And what is that you're left out with? You will have I naught square by 2 into capital T. So you have I naught square by 2 into capital T. Let me call this as 2. And remember, this is actually the numerator of the first expression. Right. So what is the numerator? What is the expression that we have here? IRMS is equal to square root of, we already have the numerator value. And what is the denominator? Denominator is capital T. So using 2 in 1, what we are going to get? IRMS will be equal to square root of I naught square by 2 into t, the whole divided by capital T. T and T will get cancelled. So you'll have square root of I naught square by 2. Square root of I naught square is I naught. Square root of 2 is root 2 only. So remember, 1 by root 2 is 0.707. It's very simple. If you need to understand how it is, first rationalize it. You will get you will get root 2 by 2. Root 2 is 1.414. 1.41 by 414 by 2 is going to be 0.707 times I naught. And this is going to be the value of how much? What is this called as? This is what is called as IRMS. Okay. Did you understand this? First, write it down. Okay. So from where are you supposed to copy? Previous slide. Huh? So let me know once it is done. That is 2 omega or 2 down. 2 omega. Sorry, correct. Sorry, I made a mistake actually. Actually, it should be 2 omega. Okay, it's a small correction. It should be 2 omega here. Because the coefficient of t is 2 omega, right? So it should be 2 omega here. That is only correction. But actually, I wanted to say that between 0 to capital T, right? In one full cycle, integral of cos or sine is always 0. RMS value. Any value is independent. Yeah, DC, la? RMS value is equivalent value of DC. I is the I average instantaneous value then changes with respect to that. IRMS and I average are always Are you all done with the first slide? Okay. Just 1 minute. Better for. This one, yeah. Is it sixth? Formula ஞாபகம். It's an Euler circuit, right? I is equal to I naught into 1 minus e power. I naught எப்படி கண்டுபிடிச்சா? So V is 5 by 18. Calculate use பண்ணிக்கோ. Calculator வந்து. 2.73 வந்தது. Answer 27. Just check with the exponents. So maybe answer தப்பா இருக்கு. But formula தெரியும் உனக்கு. Are you all done? Yeah. Listen to this. So the logic here is when IRMS is equal to 0.707 times I naught, ERMS will be how much? 0.707 times E naught. Right. So if you look at this bulb, which we discussed in the previous case, suppose this is working at 230 volt. 230 volt, how much? DC. Right. Then for this bulb, when connected across an AC source, E is equal to E naught sine omega t is there, no? For 230 volt, whatever brightness the bulb is able to give, what should be the value of E naught in this case for the bulb to glow with the same intensity? That's what the question is. So listen, E RMS is equal to 0.707 times E naught, right? I can also write it as E naught divided by root 2. So when I say E RMS, right, in this case, the RMS value is not given, but it is understood that the RMS value is going to be 230 volt, because RMS value is what? The equivalent value of DC source, which can make the bulb glow with the same intensity. So 230 is equal to E naught divided by root 2. So this will be E naught is equal to root 2 times 230, and this will approximately come out as 311 volt. In the sense, the AC source which is actually used at our home, right? I told you about the stabilizer. See, look at that value. What is the number? Came up. That is not the AC value, it is the equivalent AC value. So the 230 volt that is coming there is actually not the peak value. Many of them think that is the peak value. It is not the peak value. It is actually the RMS value. So the 230 volt is equal to E naught divided by root 2 is there, no? So when you take that root 2, E naught is how much? It is actually 311 volt. Means if you write the equation of the alternating current that is coming to our home, it will actually look like this. E is equal to 311 into sine of omega is there. No, in the place of omega, you can write it as 2 pi into f, right? What is the frequency we are receiving at home? I told you yesterday, it is 50 into t. So this will be 311 sine 100 pi t. So this is the actual expression for the instantaneous voltage that is coming to our houses, provided the RMS value is going to be 230 volt. Are you able to understand this? So that's why it's not exactly going to be 230. They will always give you the range somewhere between 220 to 240. It can work anywhere between that range, because if it is exactly 230, if there is a fluctuation in the value, right, it will not work. You can see it there. It's the stabilizer is actually taking the values up and down. Sometimes you have, now it is 229, sometimes it is 231, sometimes it is 233. So that's higher voltage. 224 lower voltage, 220. It will not go below that generally. And try to keep the value stabilized at that. That's the value of a stabilizer. Name itself is telling now. It has to keep it stable. E naught is the peak value. It can be minimum value also. But that's not how you write it. Depending on what the value of time is, that will change as plus 311 or minus 311. Are you able to understand? Now you got some perspective of what that RMS value is. You're able to understand? RMS value means it should create the same amount of intensity. Those are online. Could you understand?
Yes, sir.
Yes, sir. Okay. Whatever DC voltage you're connecting to produce that amount of brightness in that device. It's not about bulb மட்டும் கிடையாது. It can be a fan or something. But fan ஒரு ஸ்பீட்ல ரொட்டேட் ஆகுதுன்னு வச்சுக்கோ. 230 வோல்ட் இருக்கும்போது ஒரு ஸ்பீட்ல ரொட்டேட் ஆகுதுன்னா generally we don't connect it to DC. AC தான் கனெக்ட் பண்ணேன். அப்போ ஏன்னா அவ்வளோ வோல்டேஜ் ப்ரொடியூஸ் பண்ண முடியாது டிசியில். இட் will be difficult. பட் அது வந்து தியரிட்டிக்கலாக டு அண்டர்ஸ்டாண்ட் அந்த வேல்யூ ஸ்டெபிலைஸ் பண்ண then these devices can work. டூ தேர்ட்டி ஏன்னா நம்மளுக்கு கிடைக்கிற பேட்டரிலாம் பார்த்தோன்னா 1.5 வோல்ட் 12 வோல்ட் பேட்டரி தான் இருக்கும். அந்த 12 வோல்ட்னா நீ யோசிச்சுப்ப 240 வோல்ட் ஜென்ரேட் ஆகணும். யூ நீட் டு கனெக்ட் 20 such cells in series. அப்போ 240 வோல்ட் ஜென்ரேட் ஆகும். Here, shall I proceed? So now we'll try out Now we'll try out some problems that are based on the mean value, effective, instantaneous values of alternating currents and voltages. So we already know this, right? What is the instantaneous value of AC? I is equal to I naught into sine omega t, where I naught is the peak value or maximum value of AC. What do you mean by the average value of AC over half cycle? So average value of AC over half cycle is basically, it is actually 2 by pi. So it will be 0.637 times I naught, right? And similarly, when you talk about the effective value is going to be 0.707 times I naught. Similarly, if you replace them with alternating voltages, what is going to happen? You will have the instantaneous voltage, you will have the average voltage, and you will have the RMS voltage. Right? So using those values, we will solve some problems. Okay. The first one is the electric mains in a house are marked 220 volt and 50 hertz. See, actually, you would have seen these kind of problems in your 10th grade also. But there, nobody would have spoken about RMS value or something. You would have taken directly as DC. Right. So the electric mains in a house are marked 220 volt and 50 hertz. Write down the equation for the instantaneous voltage. So this 220 volt that is given is actually what? It is the ERMS value. Okay, it is not E naught. That is also one common mistake that is done. It is not E naught, it is the RMS value. So what is the value of E naught? E naught will be square root of 2 times ERMS. So square root of 2 will be 1.414 into this 220. Right. You multiply, you get a value. Then what you need to do is you will write E is equal to whatever this value is, 1.414 into 220. Right, multiplied with sine of, I already wrote it, no, what is it? Sine of 2 pi into 50 into t. So it will be 1.414. That value I'm leaving it to you for multiplication. Sine of 100 pi t. So this is the value of the instantaneous EMF. Clear? If it is 50 hertz, it's India's. US now 110 volt. 60 hertz, but 110 volt. Will they use a step down transform? I think 220 into 1.414 is 311. That is 311. Actually 230 into 1 point. Previous case I wrote no 230 into 1. That will be something greater than that. 317 or something will come. Maybe you can check that value. As long as you understood the concept, this value you can change it, right? Okay. So that will not be 311. It will be greater than that. I hope this problem is clear, right? Second, an electric bulb operates 12 volt DC. If the bulb is connected to an AC source and gives normal brightness, what would be the peak value of the source? It's simple now, you know. There is a bulb which is working at 12 volt DC. So the 12 volt is actually the ERMS. The equivalent DC value is ERMS. And what are they asking? They want the peak value. So take that to be E naught. E naught is equal to root 2 times 12. So root 2 is 1.414 into 12. Basically, it is 12 cube approximately. Approximately 12 cube. It will be 1.44 into 12, right? So how much will the answer be? So that part you can do it later. Okay. So answer will be 17. Are you clear with this? Shall I proceed? So problem number 3. The peak value of an alternating voltage applied to a 50 ohm resistance is 10 volt. So resistance is 50 ohm. And what is given? E naught is given as 10 volt. E naught is 10 volt. Find the RMS current. Can you find it? So ERMS is equal to 0.707 times E naught. So 0.707 into 10 is going to be 7.07. So 7.07 volt is going to be the RMS value. Oh, I'm sorry. They have asked RMS current. Okay, it's better to erase it, right? So yeah, R is equal to 50. E naught other. Yeah, E naught is 10 volt. So if I want I naught will be E naught by R. So E naught by R means it will be 10 divided by 50, which will be 1 by 5 ampere. It is 0.2 ampere. Right. But since they are asking the RMS current, I RMS is equal to 0.707 times I naught. So 0.707 into 0.2 is going to be how much? Basically 1.414. So 1414. How many decimals should I push the value to? So it would be 0.01414. 707 into 2. This one the 0.2. 1 by root 2 times, but 1 by root 2 is 0.707. So 0.01414 volt, sorry, ampere. If the voltage frequency is 100 hertz, write the equation for the instantaneous current. Can you write it? What is going to be the expression for instantaneous current? I is equal to I naught sine of omega. I can write it as 2 pi into f into t. So I naught is how much? 0.2 into sine of 200 pi into t. So this should be the expression. Let me check it once. But they wrote it in terms of milliampere. Both are right. Ama. Clear with this? Shall I proceed? So for the fourth one, calculate the RMS value of the alternating current shown in the figure. So what is the peak value here? I naught is 2. So I RMS will be equal to 0.702 into 707 into 2. It will be 0.1414. That's it. So it will be 0.1414 volt. It should be 1.414. Sorry. It should be 1.41. Be 1.414 volt. Oh, it's ampere, sorry. You cannot, because I average is completely different from IRMS. They both are not related. In the graph, easy I average. This plus minus in the area poidum. This is plus A, this is minus A. In the rectangle matto in the rectangle in the width I can multiply them divided with time. I'm done. area divided by total time. So total time is 0 to, you should take it till wherever. But I explained it in the previous class, Roti part in the video. I told what is the reason. எங்க discrete use பண்ண, எங்க integration use பண்ணணும்னு சொல்லியிருக்கு. Okay. IRMS is who are? Oh, I'm sorry, guys. Yeah. Sorry, it's my mistake. Sorry, it's correct. IRMS is actually not 1.414. That IRMS is equal to 0.707 times I naught only for the sine function. There's not a sine function. No? It's not a sine function. So IRMS is equal to square root of, see, I used integral for time varying function. Here also it's time varying, no doubt in that. But if you observe, you either have a peak value or a lower value. So you either have plus I naught or minus I naught. So what will happen? So here, how much is it going to be? So if I take the total time as 3, okay, so they have not given, but if I take the total time as 3, what did I say IRMS is? It is the square root of average of the square values. So if I take this positive cycle, for the first cycle, what is the square of it? What is the current value? Is it not? So 2 square, that is 4. For the bottom one, for the top one, the whole divided by 3. So square root of 12 by 3. 4. Root 4 is 2. This is the answer. But did you understand how I wrote it? That's why I told you in the beginning itself, RMS means don't memorize it like that heat formula or something. What you need to do, first find the average of the squares. So average of instantaneous squares. So I1 square plus I2 square plus I3 square, the whole divided by 3. And put it under a square root. Those are online. I hope you understood. I made a
Yes, sir.
small correction here.
Sir.
Yeah. So use that 0.707 times I naught only for sine function, because that is what we derived. No? Yeah, ERMS or IRMS. When I say for I, it is applicable for E also. Use that 0.707 only for sine function. So this is actually called as a square wave. Okay. So we'll do one last problem based on this, and then we'll proceed to the next topic. So problem number 5. The electric current in a circuit is given by I is equal to I naught into T divided by tau. Okay. For some time. It is some instantaneous current. Okay. Calculate the RMS current for a period of T is equal to 0 to T is equal to tau. So for me to calculate the value of RMS, what is the formula? Square root of integral of I square dt divided by the total time. So what is the total time? 0 to tau means tau is the total time. And here what should be the limits I should take? 0 to tau. So calculate the numerator separately. If I have I square dt, what is it? It is I naught square into T square divided by tau square, right? And I need to find the integral of this. So in the integral of this, I naught square divided by tau square is taken out. What is the integral of T square dt? T cube by 3, between which limit? 0 to tau, right? So it will be I naught square divided by 3 tau square into tau cube. So tau square will cancel this tau cube once, and you are left out with tau itself. So what is going to be the answer? I naught square tau divided by 3. So take this and substitute it in the numerator. You will get the answer as square root of I naught square tau divided by 3, the whole divided by tau. Cancel this and this. Answer will be I naught divided by root 3. So this is going to be the RMS value. Not root of I average, root of the Average of the square. Up I square dt in board. Right? Total time. Time period. Total time. How do you put up? How do you put up? That is, okay, you will use summation only when you have discrete values and continuous values. You can draw a graph for it. It will be of the form y is equal to mx. Are you all clear with this? Shall I proceed to the next topic? Right? Those are online. Are you clear?
Yes, sir.
Yes, sir.
Okay. So let me proceed to the next important topic. Nothing put here. Can you just give me a minute? I just need a minute. Yeah. Right. So now we'll discuss about the next very important topic of this chapter, which is phasors and phasor diagrams. Okay, it's a very, very, very important topic because the whole chapter is going to run based on this concept. So if you see, right, for whatever scenario we are going to discuss going forward, we'll be drawing two diagrams for it. One is called as a graph and the second is called as a phasor diagram. So all the questions will be based on that. Now the point is, what exactly is a phasor diagram? Right. So first, what exactly does a phasor represent in the first place? Right. If you take a phasor, it is basically a rotating vector. Now there is an important question that we need to ask. From the beginning, if you see, we are dealing with two important quantities. One is called as EMF and the second is the current. If you observe, none of the quantities are actually vectors. Neither EMF is a vector quantity nor current is a vector quantity. But why are we using the word rotating vector here is just to simplify the concept. Okay, though they are not vectors, we are taking the help of vectors only for understanding them for diagrammatic purpose. You should not get into the misconception thinking that EMF and current in this case are vectors. No. Right? So a phasor is basically a rotating vector, but where is it used? It is mainly used to represent sinusoidally varying quantity. So what do you mean by sinusoidally? Anything that can be written as a function of sine or cos also. Because cos also has a name called as cosine. So sine and cos both are said to be sinusoidal functions. So if you are able to represent any mathematical equation in the form of a sine or a cos, then you can either represent it graphically using that wave shape, or you can use a rotating vector to make our job simple. So basically, if someone asks you what is a phasor, what will you say? Phasor is a rotating vector that is used to represent sinusoidally varying functions or quantities. Sinusoidally varying quantities, right? First, make a note of that point. Clear? Now, suppose it is going to be a vector which is rotating, right? So what are we saying? Phasor is basically a rotating vector. So till now we didn't deal with them, right? If I have a point like this, if I treat this to be a vector, observe. So it is going to rotate like this. When it is going to rotate, it needs to have an angular velocity associated with it. So for which quantity are we going to represent them as phasors? For quantities which are represented sinusoidally. That is, E is equal to E naught sin omega t, or I is equal to I naught sin omega t. Both are functions of sine. And you're going to use them as, you're going to represent them with the help of rotating vectors. Now the question is, with what speed is the vector going to rotate? The vector is imagined to rotate with angular velocity equal to the angular frequency of that quantity. So what is the angular frequency here? It is omega. So the vector is also going to rotate with an angular velocity of how much value? Omega. That is the first point to be noted. Second, when I talk about a vector, so for rotation, I've justified. For rotation, we have justified the speed. But when you talk about a vector, it has a magnitude associated, right? So its length is represented by which quantity? Because I have multiple quantities here. I have E, instantaneous value. I have E naught. I have omega. So omega is going to help us to understand with what speed it is rotating. But the length of this vector is taken to be the peak value. So E naught or I naught is going to be the length of this vector. So its length represents the amplitude of the quantity and its projection upon the axis. When I say projection, projection basically means dropping perpendiculars. So projection means dropping perpendiculars. So I'll come from the beginning. Its length is represented, or its length represents what? The amplitude of that sinusoidal function. So if you're drawing the phasor for EMF, what will be the length of it? E naught. If you're drawing the phasor for current, it will be I naught. Okay. And its projection upon the fixed axis. When I say axis, right, it can be either x-axis or y-axis. Its projection upon the fixed axis gives the instantaneous value of the quantity. So that with one phasor diagram, you can represent everything. Did we cover omega? Did we cover omega? So what does omega represent? Omega represents the speed with which the vector is rotating. What is going to be the length of that vector? It's going to be the amplitude of it. So I've covered E naught and omega. What is the other function that is left out? It is E. No, sine will not represent. So it is E, which is the instantaneous value. How do you find the instantaneous value? You take the vector for this vector, drop the perpendicular onto the x-axis or drop the perpendicular onto the y-axis. So the distance from origin to the foot of the perpendicular will give you the instantaneous value. Don't worry, I'll show you diagrammatically, but have these points in mind. Are you able to understand all these things? So all the three are covered. Now the next question is, generally this phase means angle. So why we are actually doing this is to understand what is the relation between the input and the output. So if you observe, right, anything in this world, any circuit in this world has only one input. I'm talking about electrical circuit, has only one input, which is the EMF. You always give the EMF as input, and what do you take the output as? Current. So phasor diagram is mainly used to represent what is the relation between the input you give and how the output is generated. Okay. So the phase angle between the two quantities, what are the two quantities that we are speaking about? Just now told you, EMF and current. So the phase angle between the two quantities is shown as the phase angle between their phasors. Am I clear with the first paragraph? Are you all clear with it? Right? To some extent, you understood? Anywhere, you take anywhere. It's the length of it. But generally, you take the length of the vector from 0. Okay. So as I told you, right, the study of AC circuits are simplified. So every time, if I ask you to draw it graphically, right, you'll run away, because if it is sine omega t, the graph is easy to draw. If the function is I is equal to I naught sine omega t plus pi by 4 or pi by 5, it will be difficult. You should know how to shift the graph to the left or right. It will become a little bit complicated, and graphical representations are not much comfortable for us to analyze something. You're able to understand? See, I'm not sure if you'll be able to connect it. I'll just give you an example. Let's say there is an Excel sheet here. Okay. In that Excel sheet, I'm putting the marks of everyone in terms of numbers. And on the other side, I'm giving, instead of marks, I'm giving you bar graph. Which one will be more comfortable for you? Numbers or bar graphs? So if I'm saying compare to marks, right? Bar graph is going to help you better, no? Whichever is going to have greater length, your job is easy. You're going to look at the graph, you're saying A is greater than B or B is greater than C, whatever it is. You can analyze it. But if I give you numbers, you have to sit and mathematically run things in your mind. 50 numbers are there, no? It'll be a headache for you. So for the same reason, that numbers or graphs, that bar graph is phasor diagram. Just to simplify that process, we are using phasor diagram. That's why they have told it. The study of AC circuits are greatly simplified if we treat alternating currents and voltages as phasors. We are only treating them, they are not. We are only treating for understanding. Okay. And I have explained about the first part. I hope everything is clear with respect to what is a phasor. The next question that we are supposed to answer is, what is a phasor diagram? So the diagram that is going to have these phasors along with the angle between them is what is a phasor diagram. So a diagram that represents the alternating current and voltage of what frequency of, this is the most important thing. I'll tell you why it is important. You will understand when I start deriving things. So for you to draw the phasor diagram, you will draw both alternating current and alternating voltage on the same diagram. But what is most important for you to draw them? They should be of same frequency. Okay. Now, along with having the same frequency, if you are able to represent the proper phase angle between them. So what are you supposed to do? You will draw the graph for EMF. Sorry, you will draw the vector for EMF. You will draw the vector for current. And if you're able to represent the angle between them, which is called as the phase angle, then that one diagram which shows everything is what is called as phasor diagram, or most rarely used name is Argand diagram. Argand is something related to complex numbers. You would have learned about Argand plane. Right? It's something related to complex numbers, but let's not worry too much about it. So it's either called as a phasor diagram or Argand diagram. So if you're clear with this, I'll just give you an introduction of what it is. Are you all clear with this slide? Shall I proceed? Right. So what I need to mention is, how is the diagram actually represented? Okay, this is the diagram, but I will explain it step by step. So first thing is, you're going to divide the graph into 4 equal parts. Here we don't use the words like quadrants. Okay, because it's not something that you're drawing on a real graph sheet, right? Even if you draw it on a graph sheet, break it into 4 equal parts, but don't name them as quadrants. Okay. Suppose I have E is equal to E naught sine omega t. Then how I'm supposed to represent it as phasor is, now I'm going to connect the theory and the diagram part. So what did I say a phasor is? Rotating vector. So I will take this and place it here, right? I'll take this and place it here so that the tip, right, that is the tail, is coinciding with the origin. So tail should coincide with the origin. Now keep the origin as a center and start rotating it. And where should you stop? So you should stop this after you have completed an angular rotation of omega. After you have completed an angular rotation of, sorry, not omega, it is omega t. Because S is equal to ut plus half et square. No, the angle is going to be this thing. This whole thing is the angle. So after you have completed a rotation of omega t. Generally, we take it anti-clockwise as long as it is positive. You take it clockwise when it is negative. That is how angles are represented. You know that, right? Anti-clockwise angles are positive, clockwise are negative, right? So that is why we will put an arrow mark like this. So you're trying to say that this vector has rotated in the anti-clockwise direction. So what is the length of this vector called as? It's the amplitude. So the length of the vector, if I take this as OA, then OA vector's magnitude is how much? E naught. If I want the instantaneous value, what am I supposed to do? Drop, you need to project them. So when you project from here onto the y-axis, you get a distance from the origin to this y-axis, right? This distance is what is E naught sine omega t. You need not memorize it. Okay, very simple. If you drop a perpendicular here, how much is OA? OA is E naught, right? If I take this to be y, so what is y divided by E naught? Opposite by hypotenuse, sine omega t. Then what is y? Now you understood why it is instantaneous value. So when you drop from here, this is what is called as projection. Right? This is the graph for, sorry, this is a phasor diagram for which one? Only E naught. That is for E naught sine omega t. But what is my job? What does a phasor diagram tell? Phasor diagram is not only about E. The phasor diagram should actually be about E and I on the same graph. So if I take I is equal to, I naught sine of omega t plus phi, what is the meaning of this? I is covering an angle of phi more than omega t. So where should I be? So I is also going to start from here. It is going to rotate in the anti-clockwise direction, but it will not stop at omega t. It will rather stop at omega t plus it will make some more angle phi. So when you draw it graphically, let's say this is what is going to be the graph for. This is what is going to be the vector which is representing I. Let me call this as B. And from here, if I drop a perpendicular, first tell me what is the magnitude of OB vector. See, I'm drawing the vector length of OB less than OA because the output will always be less than input. So current cannot be more than the EMF. So it should be a part of it. Right. So what is OB vector? I naught. So if I drop a perpendicular from B to y-axis, it will be I naught sine of omega t plus phi. Then if this is omega t, then how much will this be? Phi. Now connect all the dots. What is the definition of phasor diagram given? Now you read the definition of it. A diagram that represents alternating current and alternating voltage. Alternating current and alternating voltage, which are rotating with the same frequency. Are they? Here also frequency is omega, here also frequency is omega. They should rotate with the same frequency and along with the proper phase angle between them. Along with the proper phase angle between them. This is what is called as a phasor diagram. This is what is a phasor diagram. And remember, this is just X and Y. Just X and Y, nothing else. Clear with this? Both are of different frequency, graph phasor diagram or MDR. If you're interested to draw phasor diagram, first thing you need to ensure is ஒரே முடியாதுடா ஒரே முடியாது. You cannot draw phasor diagram. If you draw it is wrong. It's a slightly heavy chapter. This one wave optics is slightly tougher. Okay, so concentrate. Edra? Modern physics. It's easy. Unga syllabus la paadi deleted. This chapter is slightly tough. See, but as far as possible, you can actually visualize, but இது புரிஞ்சிருச்சுனா போகேடா. I can explain other things. இது புரிஞ்சதில்ல. Graph மட்டும் explain. Okay. Copy பண்ணிட்டியா? Wave optics in 9th chapter. இது வந்து இன்னும் ஒரு 7th இது. 8th வந்து ஒண்ணு. 8th is very easy. Electromagnetic waves. சின்ன chapter. Are you all done? Okay. Okay. So just a small discussion. So yesterday I told you, right, one thing like you can actually relate this to real time and see. You would have seen that with the stabilizer, right? You can connect and see it. See what I had a thought in mind. Okay, this is something I got it today. I am interested in one thing. Like you people shop, like you do online shopping. Everybody, what do you buy? Generally. Any stationery, those things you can see. What do you generally buy? Lensa. என்ன home appliances? நீ என்ன வாங்க? உனக்கு என்ன சம்பந்தம் ஃபேன் கொடுக்கும்? நீ வாங்கினியா? என்ன வாங்கின? Okay. Okay. Atomberg. Okay. So why I'm asking this question is when you do this kind of shopping, right? Do you ever read the descriptions? No, right? You will first check the rate. It's good, star rating is good, you buy it off. Right. So that's what we generally do. Even I do the same thing. But okay, if we go slightly in depth, right? See, I feel like whatever you're studying should actually help you in your real time. Okay. So the thought I got is, why don't I actually connect It's not only physics, okay? Why don't I connect math, physics, and chemistry to whatever you're buying? Like how I wanted to do is, I'll tell you. See, I was going through this today, right? I've learned so many things. So first thing, I'm not going to tell everything now. I'm just telling you the idea. I'm telling you why I'm sharing it also. I'll tell you at the end. So this is there, no? You're able to see so many things here. What is it? If you look at the name itself, it is giving us so much information. So first thing, what is it? Lloyd, okay. 1.5 ton is given. What is that 1.5 ton? Is it capacity or weight? 1.5 ton na தூக்க முடியாதுமா 1500 kilograms. It is a capacity. A capacity to do what? It's some capacity to cool, right? So that capacity of cooling, is it not related to some thermodynamic parameters? Because we have learned it already. So what I wanted to actually do is, if I take all these terms here, right? If I take all these terms here, you are able to see the description. One is brand and the capacity is written here. Cooling power is written here, 5.22 kilowatts, right? And there is some product dimensions are given. Is it not something related to your units and measurements? Right? You should be, somebody is coming to fix something at your home. I feel that you should also know it, right? Or else they're going to cheat you. And this happens also. If you don't, being a science student, if you don't know the basics of what things are happening at home, they might cheat you, right? So this is there. What is, can you just tell me what exactly does this mean? Product dimension. What is 22D? It is the depth. So can you tell me where else is depth measured? Here it is correct. It is depth. So you have the starting point. From the starting point, it is the depth. From that projection till the wall is what we call it as depth. Do you know where else do we use this depth concept as measurement? I'm talking about your basic living things. Fridge, yeah, you can use it. So when you talk about a fridge also, generally you're going to keep it here. You should know how much far the fridge is supposed to be kept from the wall. Suppose, let's say you want to become an interior designer tomorrow. Let's say you want to do that. Then there's one important parameter that you need to measure. The other thing is, you can think of the sofa on which you sit. Right? When you sit on the sofa, right? So it has a projection, right? From where you're sitting till the backrest, that is also called as depth. Okay. So here it is measured in terms of centimeters. Similarly, you have the width and the height that is being given, right? Can I say that this is something related to units and measurements? This is what we are doing, right? You should know how to take those measurements perfectly. But apart from this, what I could see is, when I went slightly down, right, this part is there. Have you ever seen this? So capacity is given. Did you observe this annual energy consumption? This is not a concept that is already there in your syllabus. Right? In your current electricity, there is something called as commercial unit of energy. Do you all see, or at least do you hear what is the current bill your parents pay? It is generated 2 months once, you know that. Do you know how much value comes out? What do they generally talk in terms of? They use the word units. Okay, that's from a layman point of view. But as a science student, can you tell me what units they're talking about? It is a kilowatt hours, right? So here, if you observe what is given there, kilowatt hours. So what they are saying is annual energy consumption is the 794.34 kilowatt hours. Means you can expect that bill. But the question is, how many hours are you going to run in a particular day for you to arrive at that number? Okay, so I am trying to actually connect your textbook concept to something that is there. Okay, I thought of doing something. இப்போ இங்க ஒன்று இருக்கு பாரு voltage என்னது இப்போ உங்களுக்கு தெரியும் ஆன்சர் voltage 230 volts. What is the 230 volt? Now you know the answer. They're talking about the RMS value, right? So wattage is 1320. So certification இதெல்லாம் இருக்கு. Material, plastic or metal, why are they using it? Because what is the job of an AC? What is the job of an AC? So it has something to do with the heat that is getting escaped, right? For that, you need to choose the right materials. So it can be either a plastic or something. There are some ACs which are made up of copper and some are made up of aluminum. Ulla coil வந்து அப்படி பண்ணுவாங்க. There is a change. Okay, that will also be mentioned here. Right. Similarly, when you talk about the battery cell type, you have heard about this lithium ion battery, right? But you're learning something called as electrochemistry. Are you actually connecting it to this? Is what the question is. Everything is there in front of your eyes, but everything has an application, but it's not taught like that. Right. So this is something I had an idea in my mind today. So I will do with certain concepts which are there in my mind. But what I want from you guys is, can you give me some topics which are of your interest for which you would like to know the answers? Maybe not today. You can think and tell me. Can you give me that? At least adukavadhu Monday atam. Kudukam enakku enna any topic da. See, for example, you want to buy a book. Right? How many of you have bought books on your own? What do you generally go and ask a shopkeeper? ஏதோ ஒரு புக்கு கொடுத்தா இல்ல நான் கேட்கறது நோட் புக். ஒரு நோட் புக் கிளாஸ்மேட் என்ன டைமென்ஷன்ஸ் you'll ask for the pages alone, right? எப்பயாவது புக்கோட பின்னாடி வந்து செக் பண்ணிருக்கீங்களா என்னென்ன போட்டிருக்கோங்க? கிளாஸ்மேட் வாங்குறீங்கன்னா புக்கோட பின்னாடி வாட் ஆர் ஆல் த டேட்டா? It's a number of pages, and most importantly, have you ever heard of this term called as GSM? What is it? What is GSM? It is actually a gram per. So you remember there is a concept in center of gravity where you will actually use gram per centimeter, gram per meter square என்னது actually? GSM na gram per square meter. That's full form GSM. It's not weight, it's a density. It's a surface area density, surface density. Because mass, gram na edhukku use pandra unit mass. Meter square is used for area. So it is. So suppose tomorrow you want to buy something or you want to take printout of certain books, where you go and ask, naalik or printing shop poringa. See, all these with the long term perspective, because I do this already. It's not necessary that you are going to do, but I'm assuming that some of you might get into some entrepreneurship, something. At that point, you will need all those things. நாளைக்கு வந்து they will say lawyer வந்து சொல்றாங்க bond paperல எடுத்துட்டு வான்னா உனக்கு எவ்வளவு GSM னு கேட்கணும்னு தெரியும்னா you will get stuck. They will cheat you. Have you ever seen bond papers, rental agreements? No, paper thicker இருக்கும் பார்த்திருக்கீங்களா? It will be somewhere around 100 GS. The papers on which you are writing is actually 70 GS. So 80 இருக்கும், 100 இருக்கும். Next time when you go to a printout shop, observe all those things. தொட்டு பார்த்தாலே தெரியும். You will be able to see all those things. But that can be related to your science. Okay, I thought I wanted to do a mini series on that. Okay. But I just need an honest feedback. Will that actually help you? Will you be interested in learning or what mari boring or that's up to you. So I need feedback. Only thing is I need some reciprocation. At the same time, you can give me the topics of whatever is your interest. Or pen eppadi vaanganum kuda solla. Or pilot pen la 0.5 mm, 0.7 mm, what is the difference? You go to a stationery shop, you write what is the tip, how is the ink actually flowing? There is something called as capillary action. Have you heard of it? Ink eppadi flow avudhu mele and keelu varaiku. It's called capillary action. So whenever the fluid is flowing through a thin membrane, so that actually connect panna. That is from your fluid mechanics in your 11th standard. Illam kathukittu irukka matte theriyum enakku. Okay, can you tell me some other place where capillary action is done? Blood flow na unna arutha paaka poren nanu. Where else is it used? I'm talking about day-to-day life skills. Injection, these are all okay. I understand you're already a doctor. Adilla. For basic towel எடுத்துக்கிட்டேன்னா, when there is wetness, right, you take a tissue paper, you place the tissue paper on top of that. How is it able to absorb? I'll give you 2 quality tissue papers. How will you choose the best one? For example, சொல்றேன். You're able to understand. இதெல்லாமே capillary action. These are all simple things, but science can be connected. You're able to understand. புரியுதா நான் சொல்றது? So this is what I actually want to teach. That is the science I want to teach. Okay, it's not related only to physics, math, or chemistry. Anything that is there, I would like to have your suggestions. You can ask me any topic, put it in this suggestion box. So you would have seen this since so many days, but I didn't tell you why I kept it. Okay, so you think, and we'll keep sticky notes there. but don't scribble some nonsense and put it. Okay, make sure that it is helpful for others. நீ எழுதுனது பார்த்தா என் pages நீயே அவனா சரி விட்டு okay, that's fine. So don't do such things. If you want to write your name and give it, you can give. I'll give the credits to it. Okay, you don't want to know your name, it's fine. It's up to you. But please make use of this and give me some ideas on it. Whatever you observe, or goli soda, every open out, every kudikunundradu kuda there is a science speaking. Everybody knows how to use it. Goli soda every kudikunum theriyuma. அதுக்கு ஒரு 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 இது மாதிரி போகும். என்னைக்கா பார்த்துருக்கேன்? நீ குடிச்சிருக்கியாடா? யூ ஷுட் ஆக்சுவலி ரைட். நீ குடிச்சிருக்கியா? எந்த பக்கம் குடிக்கணும்? I've seen 90% I take them for lunch, half of them drink in the wrong way. உள்ள ஒரு கோலி இருக்கும்ல, what should happen actually? Pop okay, how should you drink? நீ எப்பயாவது கோலி சோடா பாட்டில் அப்சர்வ் பண்ணிருக்கியா? there will be a small ஒரு டென்ட் மாதிரி ஒன்று இருக்கும். அந்த டென்ட் எதுக்கு இருக்கு? பார்த்தது இல்லையா? அது சரியா? நெக்ஸ்ட் டைம் அப்சர்வ் பண்ணு. அது ஏன்னா that goalie should go and sit in that dent. It will stop it. Density இல்ல, density இல்லடா, அது ஒரு ஹோல்ற ஜஸ்ட் ஒரு ஸ்பேஸ் கிரியேட் பண்ணிருக்க for it to go and sit. அப்படி இல்ல, இட்ஸ் பிகாஸ் ஆஃப் த சைஸ். நீ ராங் சைட் வெயிட் இல்ல, நீ ராங் சைட்ல வச்சு தூக்குனா கிராவிட்டி கீழே வந்துடும். வந்து இட் வில் ஸ்டார்ட் கவரிங் த பாத். அப்புறம் லிக்விட் வெளில வராது, கோலி தான் வெளில வரும். பட் அவ்வளவு ப்ரெஷர் வராதுன்னு வச்சுக்கோ. I'm saying this as an example. So whatever you do, you can connect it. Simple things. Okay, but that's, I want to make some series out of it. Give me some topics. Anything of your interest, anything. Puri, chapati, idli, you eat. Momos, whatever it is, give me. I'll try to bring the science out of it. Okay, if I know, I'll do. Else, I'll take some time, do some research, and then give the right information. Anything. Okay? சரியா? அதுல ஏதாவது நான்சென்ஸ் வந்ததுன்னா ஒன்னதான் blame பண்ணு. Okay? So this I'll keep it outside from tomorrow. You can start filling it. நாளைக்கு லீவ் தான். நீ தான் கேட்டு, நீ கேட்டு நான் இன்னைக்கு லீவ் இல்லாம. Okay. Yeah. So we'll wind up. Those are online. Are you clear? What I asked for?
Yes, sir.
Yes, sir. Sir, happy Teachers' Day, sir.
Yeah, thank you, ma'am. Thank you.
Thank you, sir.
வாங்க அதை உங்களை டிஸ்ட்ரிபியூட் பண்றேன். Yeah, thank you.
Thank you, sir.
Yeah. வேணும்டா, அது உனக்கு போறதா இருந்தா நான் கொடுக்க ரெடியா இருக்கேன். டேய், இவங்களா எடுத்துக்கல. Yeah, thank you. இவங்களும் வாங்கினாங்களா? சொல்றேன்.